We have two examples today. We've been doing this definition, f of a plus h minus f of a all over h. And we have k of x is equal to 2 over x plus 3. So what I'm going to do is, just for notation's sake, I'm going to write this as f of x, so it makes sense with what we had up above. And I'm going to write this as f of x. These are two important problems to help you out. Have to be able to do this if you're going to be able to do calculus. No question. SB had two questions very similar to this on the test. F of x is equal to 2 over x plus 3. I first want to identify f of a plus h. F of a plus h is 2 over a plus h plus 3. Agreed? So what's f of a? 2 over a plus 3. So now what do I do with those now that I've identified what they are? What does the rule tell me to do? Subtract them and divide by h. So I'm going to take 2 over a plus h plus 3 minus 2 over a plus 3, all divided by h. Multiply this side by a plus h plus 3 over a plus h plus 3, and this side by a plus 3. You see, we have a complex fraction. Remember earlier this year, we did a worksheet on complex fractions? It was to prepare you for this moment, so that we can do this correctly. We make one fraction in the numerator. We have one fraction in the denominator. It's h over 1. And so what we're going to do here is we are going to simplify that by multiplying those pieces together. So what will this numerator give me when I multiply these things through? What do we get? Yeah, so you're already doing the canceling. I'm going to actually write it all out. 2a plus 6 minus 2a minus 2h minus 6 over a plus 3 times a plus h plus 3 over h over 1. What happens? Those cancel. Those cancel. Everything that doesn't have an h cancels. And then you're going to multiply by the reciprocal. When you do, you're going to get an h in the denominator, correct? Yeah. And so we can see that then this h cancels off. And so you're left with negative 2 over a plus 3 times a plus h plus 3. So yesterday you learned how to deal with ones if it was a, here we have a quadratic, here we have a line. And in this situation, we have what we call a rational function. That's how a rational function works out. So our last example is to look at a radical function. So what do you get if you plug in a plus h? We get the square root of a plus h plus 5. Minus, what do you get if you plug in a? A plus 5. All divided by h. Oh no, now what do we do? We're going to multiply by the square root of a plus h plus 5 plus the square root of a plus 5. Okay, let's talk about that in a little bit. Good point. Red. This red thing here. What is it? It looks big, but what is its value? 1. Does everybody agree that's 1? Am I allowed to multiply something by 1 without changing the value of that expression? So I'm just multiplying by 1. How is the top different from this top? It's got a plus. It's the conjugate. Just like in Spanish, where you change the ending, you call that conjugation, right? Well, this is the conjugate. The conjugate is where you change the ending. We change the ending from minus to plus. You multiply by the conjugate. Multiplying by conjugates is awesome. You've been doing it for a long time. For example, a minus b times a plus b. I mean, that's really cool to do, right? Because you get a squared minus b squared, right? The middles go away. Isn't it awesome when the middle goes away? Well, look at what's going to happen here when you multiply these two. You get this guy right here. You're going to take this thing, multiply it by that thing. So what do you get if you multiply the fronts together? A plus h plus 5. What's going to happen to the middles? There you get one that's negative, one that's positive. It's super ugly if you write it out, but it just entirely goes away, doesn't it? And then here you get the square root of a plus 5 times the square root of a plus 5 is just a plus 5, positive or negative? Negative. Distribute that negative, so minus a minus 5. All over h times parentheses the square root of a plus h plus 5 plus the square root of a plus 5. Now I get it. The bottom's still disgusting, but the top, what happens to the top? A and negative a go away. 5 and negative 5 go away. H and H, you get a 1 on top. I get 1 over the square root of a plus h plus 5 plus the square root of a plus 5. Now, my good friend Alex over here said, well, Mr. Gens, can't have a square root in the denominator. That's not actually true. You see, you were always told that you couldn't have something that was like 3 over the square root of 2, that you would have to write that as 3 roots of 2 over 2, right? Because this is not a rational number. Well, 1 over the square root of x, that's not irrational, it's a variable. So we very often leave radicals in the denominator if there are variables involved. And that situation is just okay. All right? There you go. Good job. You can have the rest of the time to work.